Let's now go over some examples. In each of these examples, we are going to find the derivative of the given function. In our first example, our function is y is equal to the inverse tangent of 4x quantity squared. On our left-hand side, we have dy dx. And to find the derivative of the right-hand side, we are going to use the power rule. So we have 2 times inverse tan of 4x to the 2 minus 1, which is just 1, times the derivative of what's inside. So let's just write down, we're going to be taking the derivative of inverse tan of 4x. Over here on the right, I'm going to write down that the derivative with respect to x of inverse tan of u is equal to du dx on the top, and on the bottom you have a 1 plus u squared. Let's now go back to our equation and put in that formula. On our left-hand side, we still have dy dx, and then on our right, we have 2 times inverse tangent of 4x. Now we're going to take the derivative of inverse tan of 4x. This is our u, so we're going to take the derivative of 4x, which is 4, and then in our denominator, we're going to have a 1 plus u squared, so this is 1 plus the quantity 4x squared. Let's now combine our constants. So we have an 8 inverse tan of 4x, and then in the denominator, we have a 1 plus 16x squared. And that's our answer. That wasn't too bad. Let's now look at our second one. For our second example, we are going to be taking the derivative of the inverse sine of 3x plus 1. Let's go ahead and write down the formula for the derivative of inverse sine. So the derivative with respect to x of inverse sine of u is du dx on top, and then in our denominator we have the square root of 1 minus u squared. So our derivative is dy dx is equal to the derivative of u. This is u, 3x plus 1. So the derivative of 3x plus 1 is just 3. That goes on the top. And then in the denominator, we have the square root of 1 minus 3x plus 1 squared. We could multiply out our denominator, but it's standard to just leave it in that form. And we'll highlight this because that is our final answer. Let's now look at our third example. We are going to take the derivative of the function y is equal to x times inverse secant of 2x. On the left, we are going to have dy dx, and then notice that we have two functions here on the right. We have an x and we have an inverse secant of 2x. So we are going to use the product rule. So this is the first times the derivative of the second. So I'm just going to write this as the derivative of inverse secant of 2x plus the second, which is inverse secant of 2x, times the derivative of the first. The derivative of x is just 1. Now let's go ahead and let's write down our formula. The derivative with respect to x of inverse secant of u is du dx, all divided by absolute u times the square root of u squared minus 1. I always tell my students the one way to remember this is if the u is here, it's also here, and you have u squared minus 1 instead of 1 minus u squared. I don't know if that's going to help, but hopefully it will. So we have dy dx is equal to x. Now we're going to take the derivative of inverse secant of 2x. The 2x is our u. So we're going to take the derivative of 2x, and that goes on top. So that's a 2. And then we're going to divide that by absolute 2x times the square root of 2x squared, so that's a 4x squared. The absolute goes away because we're squaring it, and then we subtract 1. It looks like our 2's can cancel, so we're going to write this as x divided by absolute x square root 4x squared minus 1. And we did it. There is our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.